Now we come to the final piece, and that is the wiring. You fitted your electronics board in, you've put on the stepper drivers, line them all up. Then with your stepper motors, the red wire is on the left hand side, so closest to the screw-in terminals. X, Y, Z. Then up the front, there's provision for 2 extruders, so the one on the left, EO is the first extruder, EO2 is the second, so we'll be using the first. So you place it there. Don't wrap them around the stepper motors, this is just to get this clear for you. We've run the limit switches down. You've pulled the ribbon cable apart, like I've said. Grab the yellow one, red one and the black one. 3 of those. Then you'll have 3 single wires. Undo the little plastic flap that stops it from coming out. Pull it apart. Then get yourself a 3P DuPont housing. You can get that off the old computers, or just buy 100 for $1 or $2 on eBay. You take off 3 of those and you place the 3 on the end, the housing on the end. The reason for that is that for the limit switches, the end stops, they are 3 pins, and you don't want to have loose connectors that you mightn't put them in, and are they the right way around? And also you get the same colours as the cabling on the end stops. Then where you have the see-through part of the housing there, you make that the front. So then you put on the left the yellow wire, right red wire, and in the middle the black wire. You put one on each end, so you have the males and the females. Then you push the yellow one into the yellow one on the cabling, black one, so then they all follow through, same colours, same position, so as you know. Then it can be wrapped up in whatever, and you don't know, oh, is the blue one the red, or is the green one the red, or is the green one the blue? So pull them apart and try to colour match. Then once you've done that, coming through the 2020 extrusion, they end up about here. So depends on where your board is. Here the cabling will be longer, over here you'll need to stretch it right out. So all what I did was I again twisted the ribbon cable, put on the 2 heat shrink, again from the earlier videos, XYZ, RGB, red, green, blue. So as you can see here, there is a red heat shrink, blue heat shrink, green heat shrink. So I can look here and I know exactly what's X, Y and Z. I could stand across the room, and if my eyes were good enough I could see the colours, I would know. I don't have to read a thing. So with your yellow signal, that goes to the top of the 3. So that's why we match them. So you put them in. So I managed to twist them. I actually done a group here in a knot, just a big circle like a reef, and then that's taken up the slack. They're now sitting flush. When I get expandable sleeving, I'll put this down and I'll have this across the side. But that's just to show you where the X, Y and Z and the extruder goes. So that's the height. Heat bed's going to sit on the top, and we've probably got maybe about 20 mil clearance. Hopefully that's enough not to melt anything. But now you have to join the rest of the wires. I've had provision for the second fan to come, so you have your probe, you have your thermistor, you have your heating resistor, and you have your fan 1 and 2. One to cool the hot end, one to cool your print. If you've soldered on a JST connector, this is the shorter length, you can get longer ones. So when you look, you might see one for $1, another one for $1.20 for 10. Just make sure the length of the cabling is long enough. You can always cut a long cable short, but you can't make a short cable longer. So there's male and female. As always, female is the one with the holes, males are the ones with the bit that sticks out. So I've got mine for the probe, only one way, and then for the fans, they're all the other way. That's so as I cannot mistakenly put in 12 volts into the probe wiring, switch on the machine, oh, poof, gone. Oh, I put on the wrong thing, too late. So set it different hand, different style, so as you know. So they only short fit, so then you have to make up the cabling. you can solder that on, or you can buy, well, you'll need to buy some cable. This is the red-black cabling, thin wire gauge. It's only carrying power to the fan, and you'll see slightly thinner than the ones for the JST. They run off the RC quads and that sort of thing, so they can handle the power. And the signal, only 5 volts for the probe, so that's fine. Doesn't take up much room, it's cheap. Buy yourself a crimper. There's all different type crimpers for all different type of terminals. This is a DuPont crimper, and it has 3 jaws for the sizes and that sort of thing. I bought this first. There's only about 20 odd bucks, and they worked fine on the DuPont type sometimes. And because they're a double action, they actually crush your wire and your cable covering at the same time. I was finding it was pushing the actual cable, being squashed and wouldn't fit in and that sort of thing. They say different size gauge wires, but it's very hard to get. If you get the exact wire, because you buy one reel off eBay and it's 1.5 mil, you buy another one as 1.4 or 1.2, you know, they try to save on plastic and all that. So all that makes a difference. But then you can get this type of crimper. These are very expensive. They're about 70 bucks. These are the PA09s. But they are a single blade. So what happens there is that when you are crimping, you crimp one section at a time. So this is one hit, does both of them together. So this one will be twice as long. But you can then gauge how thick the wire is, add the power by hand. This has got a ratchet and it closes down to the same stop all the time. So this can then squeeze down, and what you do is you buy terminals, male and female, DuPont, JST, they're hundreds for a couple of bucks, and strip off a little bit that just covers for the wire area at the front there, 2 mil, and you crimp them on. Sometimes you can buy just terminals by themselves, or terminal and the covers, the housings. Same for DuPont. It has a different type ones for different type of terminals. So this will do DuPont, JST, all that sort of thing, and you just work out which one fits. On this one, the smallest one, 1.9 does the wire and 1.6 does the plastic cover. You just squeeze it in. You can say to yourself, all right, I've got these, I've got the raw cable coming down. They pull it off and solder it to that, do a make up another crimp and put it on there. So you have to work out. Sometimes you got a meter of this cable and you decide to solder that on, and then there's a join and you have to heat shrink this, make sure that doesn't rub on there, and wrap it around and looks like a broken leg with plaster on it. So half the time it's easier, get your cabling out, cut the end off, do the terminals, crimp them, feed it through whatever sleeving you're going to use, then just slide it on once you're done. That's why the ones coming through here are blank. I haven't crimped them on because it's easier pushing that through. Then, because it goes through the 3/8 hole there. Also, heat shrink on the probe, yellow, like I've mentioned before, for signal. Z is really up the top, X, Y for normal CNC. Earth, once I know that's for the probe. So all the wiring comes back, it all looks the same, and I've heat shrink. And if you write on the heat shrink before you heat shrink it in biro what it is, when it shrinks the lettering down as well. So I've got it written down here, fan 1, fan 2, that sort of thing. So then I'll strip those back and put them in, or once I've worked that position I can cut them shorter and make it neater that way. So that's what you need to do with that cabling. With the smaller wires you can solder or you try crimping it. But what I do on the smaller wires is that I make male and female. So where the mister comes out, I'll just crimp on 2 and then I'll just make an extension. That way I can pull it out and the cabling can still sit in there. Pull it out, remove all that, and I haven't got wires dangling over, that sort of thing. If they made the lengths over 1 metre or 100, it'd be fine. I'll just put it on the end, but they don't. So you can't. Once you've done that, you then got to do the main power connectors. You need to set your voltage on your power supply to 12 volts. Apparently part of the heating of the MOSFETs and those type of things on the board is because it's putting out 13 or so volts or higher voltage than what the Arduino board likes to handle and the ramps like to handle. So before you connect anything to the power supply, plug it in, put a multimeter on, connect that, measure your voltage, and then with the adjuster, adjust it down to 12.0 volts, and that should help some of the problems. The other problem they have is with these poly fuses. Apparently they overheat fairly easily, hence the fan blowing on them and blowing on the MOSFETs. That's where the wiring is up to. I'll just run the extensions from there. I just have to connect the main power supply to the board, and then we're ready to go. This is the DuPont and JST Quad 4A, that's the other of my videos, the Quad 4A JST power rail, and what will happen there is that will fit on the side in there, and things like the power for the onboard fan will go in there, the power for the fan that's always on will go in there, any JST connectors will also go in, and DuPont, so it fits both types, and I'll just tap that off the main input, and then I can run whatever I need from that as well. They want you to have the fan for the hot end on all the time, fine, but you only want the fan for the blowing on the printed area controlled by the software. That's where we're up to at the moment. It's looking pretty good, looking neat. Notice there's no loose wires. That will go to the side and through that hole on the other side and come under. So just spend a bit of time, some dollars, some ideas, and then order and get started once all the parts arrive, and you'll zip right through. Again, thanks for watching, and we're almost there.